This video is about the Vertex Interpolator node in Unreal Engine Materials. I'm gonna explain what it is, what it's used for, and how we can use it. So let's do it. You can download the project file of this video on my Patreon. The link is in the description. Right-click in the material graph and search for Vertex Interpolator. It has one input, one output, and nothing here in the Details tab. We can use this section to add a comment to the node. All the nodes have it. We can also right-click on the node and add the comment here. So what does it do? It offloads instructions from the pixel shader over to the vertex shader. It means that it processes all logic passed to it in the vertex shader. The way Unreal or any 3D software renders things is by first taking the vertex information, then rasterizing it and filling those with pixels. So there's the vertex shader, and then there's the pixel shader. I'll put the link to this article in the description. The input is named VS for vertex shader and the output is named PS for pixel shader. So any pixel shader data we feed into this node, it only uses the vertex shader information, then interpolates between those values, and the new interpolated output can again be used with pixel shader. So that's why the input is named VS and the output is named PS. Let's use it in a material to better understand what it does. Add a radial gradient and a round node. Connect them like this. Save and assign the material to this cube. Duplicate the material and open it. In this one, add a vertex interpolator before connecting it to the base color. Save it and assign the material to the other cube. Up here, click on Show and enable collision. We could also use its shortcut Alt-C. It helps us to see the edges and therefore know where the vertices are placed. We can see that when using the Vertex Interpolator node, it calculates the value at each vertex and interpolates between those values, which creates a gradient. For example, here this vertex is black and these three vertices are white. After using Vertex Interpolator, all the pixel data between them are removed and it's turned into this gradient between black and white. Pay attention that still this vertex is black and these vertices are white. The information between them, on the other hand, is replaced with this gradient that interpolates between the value of the vertices. We can also see the effect of the triangulation edges here and here. Also here and here. Here's another example to better see what happens when using this node. Press Alt-C to see the geometry. This one has only 4 vertices and all of them are black. That's why after using Vertex Interpolator, it becomes completely black. The more vertices there are, the more accurate the final result will be, because there are more values to interpolate in between, so it looks more detailed. Here I've used the noise texture from the starter content, run it through a power node and set the exponent value to 4. This is the result with different vertex count. Now that we know what it does, let's go over some things to consider when using it. But before getting to that, make sure to like this video and subscribe to the channel. Also join our communities on Telegram, Discord and Facebook. You can ask questions or answer them, share your work in progress and more. If you're interested in supporting the channel and downloading the project file of this video, check out my Patreon. The links are in the description. We shouldn't use this node with textures that have per pixel data. It removes the details. We can use it in places where we know the value between vertices is going to be linear, or places that don't need per pixel details and all the changes are gonna occur per vertex, like solid colors. For example, here the material doesn't have any per pixel detail, so using the Vertex Interpolator node optimizes the material and doesn't affect its visual fidelity. If the visual result we get when using this node is enough, using it can highly improve the performance. Most of the time there are fewer vertices than pixels, so moving any math to the vertex shader can be a big performance benefit. But if the mesh has a very high poly count or doesn't have LOD, the extra vertex shader cost can be the bottleneck. This is because the vertex shader cost is the same no matter where the mesh is, whether the mesh is in the distance covering only a few pixels or filling up the whole screen. As we saw in the previous video, in order to use the pre-skin normal and pre-skin position nodes with pixel shader, we should first connect them to the Vertex Interpolator node. Watch the pre-skin nodes video to learn more about them. Vertex Interpolator doesn't work with the nodes and inputs that work with Vertex shader. For example, it can't work with anything that goes into the world position offset input. It doesn't work with the Fresnel node either, because again it works on a vertex level. The reason is simple. Vertex Interpolator offloads instructions from pixel shader to vertex shader, then interpolates between them, and the output can be used with pixel shader again. If something only works on the vertex level, it means there's no need to use Vertex Interpolator with it. It just makes no sense. And that's why Vertex Interpolator outputs an error. Up here click on Lit and under Optimization View Modes, set it to Shader Complexity. Down here we have this bar. PS is for Pixel Shader and VS is for Vertex Shader. It shows us how much of the shader complexity is being driven by each of these components. Right now the material on these planes doesn't use Vertex Interpolator, but if I select them and change the material to the one that uses Vertex Interpolator, notice on the bar how PS decreases and VS increases, before, after. The previous workflow for offloading work to Vertex shader was by making use of customized UV outputs. This involved manually packing the data, so it could be a little cumbersome. Vertex Interpolator handles packing automatically. It doesn't work very well with Nanite. With Vertex Interpolator, the more vertices the model has, the more values it has to interpolate between, and the less vertices, the less values to interpolate in between. With LOD system, as LODs shift on a mesh, you could see a change in detail. We could set the distance in a way so the change is not that obvious. But with Nanite, because the vertices are constantly shifting, you're not going to have a stable level of detail and fixed values to interpolate between. Vertex Interpolator can optimize the shader. Most of the time pixel shader is more demanding than vertex shader, so whenever possible offloading the instructions to vertex shader helps with optimization. For example, when transforming the world position to local position, the instruction count is 225, but using it with Vertex Interpolator decreases it to 206. We can use it with instanced objects. I've created this material to add world aligned gradient on meshes. When used with static meshes, it works just fine. But when we use it with meshes that are scattered with the foliage tool, it recognizes the collection as one object. We can see it better in places like this where there's a height difference. These are scattered with the foliage tool, and the whole collection of instances are being treated as one object. We can see it in the way the gradient is placed on them. To fix this and have per instance gradient, we can move the material to Vertex shader. Add a Vertex Interpolator here and connect it like this. Save the material and it's fixed. Now the gradient is per instance. And that's it. Click here for more Unreal stuff, and thank you so much for watching. Like this video, subscribe, and join our communities on Telegram, Discord, and Facebook. If you have any questions, leave them in the comment section below. So, see you in the next one.